These are some additional notes on the parabola that I thought would be helpful, and so I passed out a little addendum to your notes, and I just want to go over the information on this. If you were absent, you can find this handout filled in on the notes page. So parabolas are the only conic sections with symmetry in only one direction. Ellipses, hyperbolas, and parabolas all have two-way symmetry. They have horizontal symmetry, where the graph looks the same both up and down, above and below the x-axis, and they have a vertical line of symmetry, where the graph looks exactly the same to the left and the right of the vertical axis. But parabolas are different. They either have a vertical line of symmetry in which they look the same to the right or the left, or they have horizontal symmetry where they look the same up and down, but not both. A graph with vertical symmetry has an x squared in it, but not a y squared. It has an x squared because we can have both positive and negative values for x, and it gives me the same y value. The one with vertical symmetry is a y-squared graph because it can have a positive and negative value for y that go with the same x value, which of course is not a function, as we know. So that means when we look at the graphs of parabolas, they're the only conic section with only one squared variable. The other conic sections all have two squared variables, as we can see below. Circles, ellipses, and hyperbolas all have an x squared and a y squared term in them, as well as r, which tells you how far out you go from the center. The center is hk for each of these graphs, and then r tells you how far you go out from the center. And I gave a subscript to the r's in the ellipses and hyperbolas because r in the x direction and r in the y direction might be two different numbers. Definitely will be two different numbers in ellipse, and maybe two different numbers in the hyperbola. The hyperbola also has two forms of the equation, one where I do the x squared term minus the y squared term, and one where I do the y squared term minus the x squared term, which determines which direction the hyperbola opens. Now, to add to our list then, a parabola has the general equation x minus h equals some coefficient, I'll call that a, times y minus k squared, so this has the y squared term, or y minus k equals a times x minus h squared. And in this case, hk is not some point in the center of the figure, but it's actually the vertex of the parabola. Now, if you are given the equation of a parabola and asked to draw the graph, what would be the steps that you would go through? You'd start out by plotting the vertex using the points h and k in the equation. Then you'd have to determine from the vertex which direction is the parabola going to open, because there are four possible directions the parabola could open. So if we have an x squared equation, you know it's going to either open up or down. If the leading coefficient a is greater than 0, it will open up, and if a is less than 0, it will open down. If the parabola opens right and left, then it's a y squared. I guess I don't really need that line there. It's a y squared. So if a is greater than 0, it will open to the right, which is the positive x direction, and if a is less than 0, it would open to the left. Once you know which direction the parabola opens and you have the vertex plotted, then you can use that leading coefficient and that stretching factor, kind of like the slope, to plot two other points. So here's an example. Y minus 2 equals 2 times x minus 3 squared. I locate the vertex at the point 3, 2. Then if I go one side, and I also notice because it's an x squared that it's going to be going up, and 2 is a positive coefficient, so it's going to be pointing up. So I go sideways 1 and go up 2 because my leading coefficient is 2. Then I can go sideways 2 and I can go up 4 times 2, which is 8, go 8 units up to get this point. Once I have these 2 points, then I can plot another point on the other side of the parabola using symmetry. If I have given the graph, I could also use those same characteristics. I could use the vertex to find h and k, and then going sideways from the vertex, I could go 1 unit and then figure out what my first stretch is. That would be the coefficient a. Okay, so those are some tips on graphing the parabola. Now, on the second page of the Parabola Summary handout, we talk about what if you are given, what if a is a really small number? Okay, so in this case, a is 1/8. So it would be kind of difficult to go over 1 and up 1 and kind of figure out what value that is, and also kind of hard to plot because 1/8 is a really small number. So when we have a really small value for a, we're going to look at the fact that a is 1/4p, where p is the distance from the vertex to the focus. So if, for example, a was 1/8, I could say 1/8 is 1/4p, so 4p is 8, and that p is 2. That means the focus is 2 units from the vertex. Now that doesn't actually give me, so if I were graphing this, that doesn't give me another point on the parabola, but I could put the vertex here and recognize from the focus, if I draw a line perpendicular to the vertex focus line, that line through the focus has to be 4 times the distance of p. So in this case, if p is 2, then this whole distance has to be 8. So I could go 4 in this direction, and I could go 4 in this direction, and that would give me 2 more points on the parabola, and I could graph the parabola. So that's what I talk about here, kind of the steps of doing that. Also, if you have the equation given, or if you don't have the equation given, but you have the graph with a focus on it, then you could go backwards. You can figure out the focal distance, that focal radius, if you want to call it that, the focal distance, and figure out what p is. Use 1/4p then to find a, and then use the vertex and a to write your equation. So those are some nice tips that I thought would be helpful in this Parabola Summary worksheet. It might be really useful on your Desmos assignment.